Okay, good afternoon. Form 5. This is Form 5 Monday group. This is a second lesson in the years of 2021. This is our second lesson. Okay. And last week, you still remember what you have learned or not? Last week, you learned about this resolution of forces, right? Not resolution, resultant force. You learn resultant force, correct not? And also you learn this Newton's second law formula, F equal to ma. And also you learn this pulley system, correct not? Pulley system and also lift system. What happened in the lift, right? You learn 4 things in our last lesson. Resultant force, calculating resultant force. Okay, after that, second one, you learn F equal to ma, Newton's second law. And after that, you learn this pulley system, calculation involving the pulley. And the last one, you learn calculation involving in this lift system. Okay, so for tonight lesson, right? Okay, we are going to learn one very important topic, resolution of forces. Okay, resolve. Okay, later on you see what is said. So I start sharing the paper with you all. Okay, so is here. All right, come look at here. Resolution of forces. Okay, first class, let me explain to you what is the meaning of resolution of forces. Okay, resolve means you break up the force. Okay, break up the force lah. Okay, why we need to break up the force? Why? Okay, the reason is like this, In last lesson, right? Yes, someone calling me. Cannot see. Can see or not, you all? You all can hear me or not, class?
Can see, can hear, sir.
Because I heard someone calling me. Don't know why something happened. Okay, last lesson, right? You only learn something like this, when the forces are same direction, you add up. When the forces opposite direction, you minus. Correct not? And also you learn something very important now. When the forces are not acted in different direction, so you are using triangle method, parallelogram method to do. Correct not? Still remember that or not? The two methods are drawing triangle, drawing a parallelogram to find, right? Okay, so what you are going to learn tonight, resolution of force. Resolution means you don't do drawing anymore. No drawing triangle, no drawing parallelogram, but you just do calculation only. How to do calculation? Okay, you have to break up the force. When the forces are not horizontal, not vertical, right? Like this one, for example, like this lah. This force, right? F. This force is not horizontal and also not vertical. Then you have to resolve it. Resolve means you break it up. Break up to x component. This is fx, sorry. Put not fy, x. Fx, can you change this? This is fy. This is x component. This is y component. Okay, so here please change to x. This is x, okay? And this one is y, okay? Y component, x component. Okay, the rules is quite simple. Okay, you remember like this. This is a force F. This is the angle theta. So to break the force, to break it up to x and y, the rule is like this, The component now where you have the angle together, you have the angle here, right? So if F cos theta, f times cos theta, so you get this one, fx. So this one, please change this is fx, f cos theta. Okay, the component close to the angle is cos. So remember, because I'm using trigonometry, like you don't need to, I don't need to explain here, like when you learn in mathematics. So now I just want to tell you that the component near to the angle given angle, so it's cos. So f times cos theta, you get this answer. Whereas the one far away from the angle, for example, this one, the angle is here, this component is far from the angle, isn't it? If f sine theta. You take the component, take the f multiply sine theta, use a calculator, calculate, you will get the answer. Okay, okay, the rules of resolution, so we will pick up the force with x component, y component one. Every time the same one. You break the force to x and y, okay? X component, y component. And please don't memorize, say x must be cos, y must be sine. No, not like that one. You must see where's the angle, you know. When the angle is located here, so the one near the angle, so it's cos f times cos theta. So you get this one. When this is f cos theta, the other one will become f sine theta. It must be x or y component one. No other one must be x and y. Okay? Yeah. You know this already. The rule is like that. Okay, now another types of resolution is like that. Okay, now you see here. And now if the force is like that, you see here, you put something on a sliding what like this lah. So the weight W is here. And this W is considered a force, you know, the weight is considered a force. This force can be resolved or can be split to this one. We don't follow x and y anymore. Not follow x and y, no. This one will follow the surface of the plane, follow surface. Another one is 90 degree. So like that, you know. So for the case of this kind of question, we don't resolve it to x and y. So you resolve it to follow the surface of the plane. Surface here, then another one is 90 degree. Okay, so the method of resolution of force involving this is like this. If given this angle is theta, this angle automatically also become theta one, same one, you know why? You see this diagram. When this is 90, this one 30, so here is 60, right? Then this line, you draw a line 90 degree, then automatically this is 30 lah. So it's proven this angle and this angle actually are the same. Same one, you know. Then that's why I can say this theta, here also theta. This component near to the angle theta, so it's cos. So it's W cos theta. That's why here is W of cos theta. Okay. When this is W cos theta because near the angle, right? This one far from the angle, so it's W sine theta. So this is W sine theta, W cos theta. Okay, don't worry about the sine theta, cos theta. The one you just need a calculator only. Understand? Yeah. So remember how to resolve the force. Like this one, you resolve to x and y. Okay, x and y. So when you see the angle given is here, so this one is cos, f cos theta. This one no angle, far from the angle, right? So f sine theta. Okay. First method is like that. Follow x and follow y. Then the second one is like this. This one we don't follow x and y. We follow the surface of the plane. Follow surface here. One here, the other one must be 90 degree. And this angle, same. I told you already just now, same angle one. The angle is here, so this is cos. W cos theta, you get this one. When this is W cos theta, automatically this one is W sine theta. Understand? Yeah. So this is a way you break up the force. You break it up. Okay. Why you need to resolve or why you need to break up it is because you want it to be able to be calculated. No need to draw triangle method. No need to draw parallelogram. You can use just solely using calculation can solve. Understand? Okay, resolution. Okay, now we look at example 6. 6 is quite simple. Okay, now you see here. It's given here 200 Newton. The angle here 50, right? If you are given angle, so this one is cos log 200 cos 50, correct? No? I told you, right? The one near the angle is cos, So 200 times cos 50, just press your calculator, you get this number. Okay, you just press 200, press your calculator, cos 50, so you come out this answer, 128.56 Newton. So meaning that after you have break up the force to x and y, meaning that this one doesn't exist anymore, this one no more already, this one you can cancel off, it become x, this value. Y component, this is cos, and this is sine, 200 times sine 50. So press your calculator, you get this number. So the moment you resolve it to x and y, you already right. X is this value, y is this value. Automatically, the original force disappeared. So in our calculation, we don't need to involve this anymore. Only take the x and y component. Understand? Okay, Okay, second example. This one. Now is given here. This one is 75 meter per second. The value 75. Now angle given is here. So this one automatically become cos because angle is here, so this is cos. So it's 75 times cos 70. Okay, understand? When you see the angle is here, this one is cos. 75 times cos 70. So press your calculator, you get 25.65 meter per second because this one meter per second. Okay. When this is cos, this one definitely is sine. Okay. So 75 times sine 70. Only take one angle, take this one. So this one is cos. When you take this angle for here, it becomes sine. 75 sine 70. Press calculator, you get 70.48. Quite easy, right? Resolution of forces, correct not? Can understand? All these people here can understand. Chai Pei Xin, understand or not? Chai Pei Xin, do you understand me?
Understood.
Then, Carmen, do you understand, Carmen?
Understand, sir.
Then, Chloe, Chloe, understand or not? Chloe Tan.
Yes, sir.
Then, Amy, Amy Tan, understand?
Yes, sir.
Justin, what about you? Okay or not, Justin?
Can, sir.
Then, Jing Sun, Leong Jing Sun, okay, understand?
Okay, sir.
Okay, okay. Kalai, what about you? Kalai?
Understand, sir.
Can understand X component, Y component, Okay.
Yeah.
All right. Okay, now, next one. The next one is example 7. This one, now you see, it's given here, this one, the mass is 50 gram. Mass is 50 grams. So first thing you must change to Newton. Okay. 50 gram change to kilogram, you divide by 1,000, you get 0.05 kilo. We know 1 kilo 10 Newton, so times 10, so you get 0.5 Newton. So immediately, the weight of the box, you draw horizontal line, so it's 0.5 Newton. You calculate already 0.5 Newton. So it must be vertical one, weight come down one. When this angle 40, automatically here become 40. Sure one is the same one. This angle sure same one. Okay, so since the angle 40 is here, so this component become cos 0.5 times cos 40. Okay, whereas this one cos, this one will become sine. It must be two components must be 90 degrees to each other one. One must be follow the plane, the surface of the plane. The other one must be here. This one cos, this one sine. So press calculator 0.5 sine 40. This question, they ask you to find what is the magnitude of weight parallel to the plane, parallel to the inclined plane. Mean here, you ask to find this only, not this one. Only calculate this one. 0.5 sine 40. Okay. Press calculator. You get this number as your answer. Okay. Understand? So this resolution not difficult. Later on, you can see in the objective question that there's a lot of challenging question, you need to do. Okay. It's very important to understand this one first. Okay. Okay. Now, I want to continue the questions last lesson because since you know already resolution of forces, you know how to break up to X component, Y component, right? Okay, I would like to continue to finish up this question. Our last lesson one. Go on, one moment, I'm going to find where's the question. Here. Yes, here. This question, you remember or not? Behind, you turn your paper open. Okay, this question. All right, this question, last week, I think we have discussed using triangle method, using parallelogram method. Correct now, you see, Okay, come and make it smaller. What you did was like this, right? Last lesson, okay? Two forces pulling the boat. So first one using triangle method. So you join this force, put it here, so continuously, right? Like that. Then join up. You find this value. This is the resultant force lah. This one using triangle method. Last week we learned, right? Okay. After that, last week also we learned parallelogram method. This one, okay? So do the same lah. Draw parallelogram, right? Here 5 cm, 3 cm. Draw these two curves, then join up, okay? And also you get the final answer. Okay, now we don't use triangle method, parallelogram method, Now you see section B and C, how we solve it. Okay, now you follow the lesson slowly, understand? The question still the same. Come back to this diagram. First, determine the resultant force. Okay, resultant. So X is 10 cos 30. Why that? Because, okay, you see here, this is 10. This is 30, so this is 10 cos 30. Okay, for x-axis, because the question say resultant force along x-axis, so along x lah. Along x means here, this one put it down here, so it's 10 cos 30, so it's here. Press your calculator, you get this one, 8.66. Okay, so the first one is here, This one, because they ask us to find along the x-axis, so this force can be break to x and y, correct not? Sorry. Y go up lah, okay, like that. X and y. So x component is here, y component there. Same thing go to this one, or this one also can break to x and y. I say it again, you all listen. This force, when you resolve to x is here, y is here. Same thing go to this force, you can also break to x component, y component. You see or not? All the forces you can break to x and y, okay? So for this one, x-axis is here, 10 cos 30. So here is 8.66. Whereas for this one, because the angle is 30 is here, that's why this one becomes sine. This one is cos. So 6 sine 30, so it's this one. Because since given angle is here, so this one should be the cos. 6 cos 30 is here. Then this one is 6 sine 30. Okay? Sine 60. Why 60? This one is 30. Sorry. I made a mistake there. This one is. This is not 60. It's 30. Okay, class. Can you change this one to 30? Yeah. So this number also wrong. Okay, I say it again. 10, because this question asks us to find x-axis of x. So x is here, x, y. For this one, x, y. Understand? So here, angle 30, so this is cos. So 10 cos 30, so you get this one. Then for this one, the x-axis one is here. Since the angle 30 is here, so this one is cos, then this one is sine also. This is 6 sine 30 degree. Okay, can someone please check with the calculator? 6 sine 30, I think it's 3, correct not? 3, change to 3. Okay, so here is 3 kilonewton. Then the resultant force, resultant means this 8.66 is going to the right. This 3 is going to the left. So they are opposite direction. So to find the resultant is you minus 8.66 here, minus 3 here, okay, minus this one 3. So you will get what answer here? 8.66 minus 3, so it's 5.66, okay? 5.66, okay, roughly like that, 5.66, So far, understand or not? The x component, the x-axis one. So this one bring to x is here, cos, 10 cos 30. This one bring to x-axis is here. This one is sine because angle is here 30. So here becomes sine 30. Sine 30. Okay. Press calculator, you get 3. Resultant is 8.66 to the right, 3 to the left. So you minus, right? Okay. Now they are horizontal already, opposite direction. That's why you minus 8.66 minus 3 here. So you get 5.6. Okay. That was resultant force along the x-axis. Okay, next one is resultant force along the y-axis. Y-axis, so it is up here. Okay, I slowly draw. Go up. It's here. Okay, go up. So for this, 10 cos 30 is here. So here 10 sine 30. Send 10 sine 30. Like this one, 10 cos 30 is here, sine 30 is up here. The y-axis is 10 sine 30. The sine is here. You get 5. Press calculator, you get 5. What about this one? This one you break to y component is also here, correct not? So 6, the angle 30 is here. This is 6 cos 30. So meaning that this one can be on the left side one and can be on the right side. On the right side one is 10 sine 30 is here. For this one become 10, 6 cos 30. This is 6 cos 30, you get 5.2. Can understand? So meaning that you can see the diagram. For this 10 kg, you break to x here, y here. For this 6 kilonewton, you can also break to x here, y here. That means this y belong to the left and also belong to the right side one. Okay, so when I take this 10 kilonewton, right? So 10 cos 30 is here. So here is 10 sine 30. That's why here sine 30. Only look at this angle, sine 30. Cos 30 is here, sine 30 is here. Okay, that's why you calculate, you get 5. Whereas for this force 6 kilonewton, right? Angle 30 is here. So this is 6 cos 30 is here. The angle here, so it's cos 6 cos 30. This one is 6 sine 30. Okay. Now, how to find the resultant? These two, you minus or you add up. Minus or add up. Okay. This 5 Newton is going up. 5.2 is also going up. So both of them same direction. So you add up as a resultant force. So you add up 10.2. Okay, you add up. Okay. Okay, after that, determine the resultant force. Okay, now you know the resultant force for x-axis, resultant force for y-axis, right? So you can use Pythagoras theorem to find the resultant force. So you do like this. This one is, because this one is to the right-hand side, okay? When you minus 5.6 is here, 5.6, okay? So it's here. Is towards here because this one is bigger than this one. So the resultant force is to the right, 5.6 here, 5.6 to the right. Whereas the vertical one is 10.2 going up. So 5.6, 10.2, use your calculator. This one changed to 5.6. So what answer you get? This one cancel 5.6. So use a calculator. So 5.6 square plus 10.2 square. So square root 11.64. So the answer is 11.64 kilonewton. I see this answer calculation, right? The answer same as the one you did last time, okay? 11.66. So here 11.64. So you see or not? Yeah. I hope you all understand what I say, I know this time is a bit difficult to understand. Okay. But don't worry, one day you will understand one, okay? One day. So what you need is you just need to work hard. So one day you will understand, okay? So okay, so far find it hard to understand, Yong Jia Wei, okay, can I understand?
Yes, can.
Can Kelvin understand?
Understand,
Kevin Lim.
sir. Yes, understand.
Okay, Ken Leong, what about you, Ken Leong?
Yes, sir.
Okay, all right, come. Okay, we have finished this resolution now. Okay, now we move to another part. Okay, another part. Okay, come. Another part is forces in equilibrium. Okay. Forces in equilibrium means the forces balance up each other. Example is force to the left, force to the right. If they are same, means they are balanced. So the forces are balanced. Okay. So when all the forces are balanced, means left, right, same, up, down, all same. So when all the forces are the same, right, acted to the opposite direction, are all the same, left and right same, cancel. Up and down same, also cancel. So meaning that if you make the total force, the net force becomes 0. So meaning that when all the forces are in equilibrium, equilibrium means the force to the left, to the right, to up and down, all same. So when they are same, they will cancel out each other. So equilibrium also doesn't mean the forces combine everything becomes 0, because when the forces act in opposite direction, when they are the same, they will cancel out each other. Left cancel right, up cancel down. So everything cancel, so they are balanced. So equilibrium. So the principle of forces in equilibrium state, okay, highlight now. When forces act upon an object, the object say to be in the state of equilibrium. You see? The object is said to be in equilibrium when highlight resultant force acting on the object is 0. I told you, right? When left and right same, it will cancel. Up and down same, it will cancel. So it will make the resultant force, the total force become 0. Okay, that's why we say when forces act upon an object, objects say to be in a state of equilibrium. Okay? When the resultant force is 0. When the resultant force 0 means when you add up all the forces, this is 0. No net force, okay? No net force acting upon it. Resultant force and net force same. When the equilibrium is reached, right, the object is in 2 states, okay? When all the resultant force is 0, forces are in equilibrium, right? The object will be in 2 conditions, okay? Highlight 1 and 2. Number 1 is object stays stationary, object not moving. Another one is the object is moving, but with constant velocity. If you move with constant velocity, yes. Why? I'm having class now. Why? Can. They can borrow, but we have to follow procedure, follow the schedule lah. Don't worry. We are arranging the date for them to come and collect the book. Okay. Can, but we will inform them now because due to this COVID, right? We cannot let all parents come at the same day. We are preparing the table, the schedule for them to come. Okay. Yes, can, no problem. Yes, correct. Yes. No. Actually, the book loan is provided, but just you have to wait lah. You tell the parent have to wait. We will inform them when to come. We are starting with the Form 5 student first. Form 5 are coming now. Okay. Okay. Just buy the exercise book can already. Okay, Mr. Michael. Okay. Okay. Okay, sorry, class. Okay. I said it again. Forces in equilibrium means when the forces are all cancelled out, so it becomes 0. Total force becomes 0. This time we say the net force or the resultant force is 0 lah. When they are in equilibrium, means no net force, no resultant force. They are 0. Okay. When the object is in the state of forces in equilibrium, right? What happens is the object is either stay static, not moving, you see, stay stationary, or the object is still moving but with constant velocity, no acceleration, constant velocity. Okay, I take one example. You see here, I take these two I use this one to explain to you. This object acted by 2 forces. One is go down, weight. The other one is normal reaction, go up. Okay, when the 2 forces are equal, one go up, one go down, equal. So when you total up, positive minus negative, so it becomes 0. Meaning that the net force, resultant force is 0 lah. 0 means this object is in the state of forces in equilibrium. Equal, cancel out already, up, down, cancel out. So object is in forces in equilibrium. When equilibrium means this object will stay stationary here, not moving, stay on the floor, not moving. Okay, or also possible the object will move but not move with constant velocity only. Either you stay stationary, but most probably in this case is on the floor, right? So it will stay stationary on the floor because the forces are the same. Okay, Now this second example, object, this is a string, right? So two forces acting on this object is the weight, once again the weight, and this is a tension inside the rope, inside the string. When the tension and the weight same, meaning that object net force is 0 lah, because opposite direction, same value, when you add up, it becomes 0. So when the net force is 0, means this object stay in forces in equilibrium. Once forces in equilibrium means the object stay stationary, not moving. So this object will hang there stationary, not moving. Okay? Understand? This means by forces in equilibrium and all. All this you have to memorize the whole statement here. Here, all these are memorized. Okay, now the further explanation. Okay, listen here. Based on Newton's second law formula, F equal to ma, right? A is F over m. Now you see here. Okay. When the equilibrium of force is achieved, what happens is then F 0. Hence A also 0. When the F is 0, the A also 0 lah. This one is that common sense lah. When no force is applied, of course the object won't accelerate. So when F 0, sure the A 0. This one just your common sense only lah. When this one 0, you calculate, so A also get 0 lah. Thus, when the acceleration 0, mean object will remain stationary or move with constant velocity. That's why we say our conclusion is based on this formula lah. We say when net force 0, 0 divided by m, you get 0 for A, right? Once A is 0, we say acceleration 0 means velocity constant, right? No. F0, A0. When A0, it means the object remains stationary, not moving or moving with constant velocity. This is further proven what these are definitions of forces in equilibrium is correct lah. Okay lah. Okay, the rest are all Newton's third law. Newton's third law highlight what Newton's third law say. Every action there is an equal but opposite direction reaction. Please add something here. Add you say you add no. To every action there is an equal but opposite direction reaction. Okay, don't write write reaction. Okay, I'll repeat again. To every action there is an equal but opposite direction reaction. That is a statement of Newton's third law. Every action, you see this diagram, this is action. This is normal reaction. So Newton's third law says, every action will be an equal but opposite normal reaction, or we say reaction only lah. So this is action, this is reaction. Understand? Newton's third law says this is action, this is this is equal one, reaction. Okay, this one also the same. This is action, this is reaction. Okay, weight is action, reaction is tension. So these two also the same. Okay, the third one, an object floating in the water. Okay, you see the object floating on the surface of water, floating lah. So when the object is floating, there are two forces. One is of course the weight. Another one is floating force. The force produced by the water trying to support the object. So it's called buoyant force. Please highlight buoyant force, or we say upthrust force. Okay. This one also you will learn very detailed later on. Any object, you put it inside the water. Okay, well, once you put it inside the water, automatically there will be a buoyant force. Because this buoyant force is always there trying to support the object, prevent the object from sinking. It will it will try to make the object float. So that force is called buoyant force or upthrust force. Okay. So in the case of this, right, weight and upthrust force always equal. When they are equal, means the object floats stationary. It will float stationary on the surface of the water. It won't sink. It will float stationary. When buoyant force go up, same as the weight go down. Okay, so resultant force 0, net force 0. Once net force 0, so we say the object is in the state of forces in equilibrium. Forces in equilibrium means this object will stay stationary. Okay, understand? Kalai, do you understand?
Yes, sir.
Can
Can.
Okay, come. So now C, now we continue with D. Okay, come, D is here. Now this one is inside the leaf. Inside the leaf, there are two forces also. One is a weight, one is a normal reaction. So Newton's third law is every way actually. Action, opposite direction, reaction. Okay, action, reaction, same one. Okay, that's why we say weight and normal reaction same. When these two forces same means a man will stand stationary lah. Net force 0 ma. So no acceleration. So it will stand here stationary lor. Even though when the move is moving up or moving down with uniform velocity. Okay. The name lah, you learn the names of the forces lah. Okay, next one. This object now placed on a table, so you have weight, you have normal reaction, and also now this time you add something to pull it, so you have pulling force, and then at the same time you have frictional force. Once you pull it, sure got friction one, because when you pull it, it start to move. When it start to move, you have friction go opposite direction. So there are four forces, Weight will be same as a normal reaction, you see. Weight, normal, same, cancel out. Whereas a pulling force will be same as a frictional force, okay? When all these forces are same, weight cancel the normal reaction, pulling force cancel the friction, all cancel already. So we say the net force, when you add up 1, 2, 3, 4, when you total up, you get 0. Positive cancel negative, right? So it becomes 0, right? So forces in equilibrium. So what happens is the object, in this object, because you are pulling it, so now the object will move with uniform velocity. Now this object not staying stationary, it will move, because you are pulling it. So when you are pulling it, it will move lah. Move but no acceleration. It will move with uniform velocity. Okay. Now when the forces is equal, you see you can move on, move in uniform velocity. Okay. Can understand all these people? I hope you all listen to me, must listen now. Okay. Online class is like that now. Your self-discipline is very important, okay. You must have your discipline to listen, listen to your teacher. Okay. 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 F, aeroplane. Now you look at aeroplane. Four forces also. These four forces for aeroplane, you have to memorize the name, The weight go down, the lifting force go up, lift up the aeroplane. Okay. And then the engine thrust, so you have forward thrust. This engine, this thrust come from the engine, forward thrust. Okay. And at the same time, because the aeroplane fly, sure got air resistant one. So the air resistant go opposite direction is called dragging force. So remember, lift, weight, thrust, and drag. The name you have to remember. Lift, weight, this one is thrust going forward, then go backward. Opposite one is called drag. D-R-A-G, drag, dragging force. So when all the forces you total up, it becomes 0. Mean lifting force same as a weight, opposite direction, cancel out, so becomes 0. They want go to the right, go to the left, same, then cancel out, so it becomes 0. So if we make the total net force, for resultant force 0. Okay, weight and lifting force same, driving force and dragging force same. So what happens is when forces in equilibrium, two conditions, right? One is aeroplane stays stationary, but this case because the engine started already, so the aeroplane is moving, but with constant velocity. Please highlight aeroplane flying at particular height at constant velocity. Okay, constant velocity. Aeroplane is flying with constant constant velocity. Yeah. Okay, one last example, the car. Okay, so the car moving also got 4 forces. The weight, normal reaction. So the name of those names you have to know. Name of the forces. The weight, the normal reaction, the engine thrust, and the drag, air resistance. When the car moving, sure got air resistance one. Weight, normal reaction, engine thrust, and air resistance 4. Understand? Weight and normal reaction same, whereas the engine thrust and the air resistance same. So all together, resultant force 0. So when resultant force 0 means the car will travel with uniform velocity. Okay. So the conclusion here is like this, when all forces are in equilibrium, right? What happens is the object got 2 conditions. It's either stay stationary or if you move with constant velocity. So remember the 2 conditions. Okay, and then what is the meanings of forces in equilibrium? Forces in equilibrium means when you sum up all the forces, you get answer 0. Meaning that resultant force is 0, or the net force is 0. When the net force is 0 means forces are in equilibrium. Very obvious now. For example, you take an aeroplane. This aeroplane, the one lift force weight cancel because same. This one same, cancel, opposite direction, cancel, becomes 0. The one thrust and the drag, same value, opposite direction, it will cancel, so becomes 0. So when you total up, the total force is 0, resultant force 0, net force 0. Okay, understand? It take a long time to understand, because this concept you need to know. Okay, now the last example, the balloon. You go and learn all the forces involving here. When the balloon is floating in the air, so there are 2 forces. One is the weight of the load. Weight of the load plus weight of the gas inside. Okay, everything. Another one is the force trying to support the balloon. Definitely something support the balloon, or else the balloon will drop. There must be a force supporting the balloon or not. So this force is called buoyant force. So any force that's supporting object from coming down, sinking into water, coming down from the air, so we call the force buoyant force. Okay, remember, buoyant force. Okay, so these two forces must be balanced, buoyant force and weight of the load plus weight of the gas same. So net force 0. When net force 0, so what happens is balloon remains stationary in the air, not moving. Balloon stay in the sky, stationary. So, okay, can understand the concept of forces in equilibrium. Okay, now we look at a few examples. Okay. This one I think no need. Just see example 1. Figure shows a stationary wooden block, 2 kilograms. This one 2 kilograms, resting on the table. So you have W weight, you have the normal reaction. Okay. Calculate the weight of the wooden block. Okay, weight is mg mass times gravity. Okay, that's why you see the answer. W equal to mg. Mass is 2, g is 10, so it's 20 Newton. Okay, and the next one, normal reaction, we know that this object, seeing the object is not moving. When the object not moving in stationary, right? So the two forces must be balanced. So W must equal to W. Straight away, you know the answer is 20. Okay. Then okay. And now, next one. Next one is another important concept. 3 forces in equilibrium. Now, how to check the forces are in equilibrium or not? So what you do is like this. When you have 3 forces, P, Q, R in different direction. Okay, what happens is, okay, this statement is very, very important. When 3 forces are in equilibrium, the triangle of forces is in one direction. Read again. When 3 forces are in equilibrium, the triangle of the forces are in one direction, meaning that when these 3 forces are equilibrium, right, you can join the 3 lines to form a triangle in one direction. I repeat again, meaning that you can take this line, this line, this line, follow the direction. You join them up, it can form a triangle in one direction. Okay, example, you see this one. Okay, you see, Q, I put it here. I never change the direction, Q is here. Then P is here, I follow here. Okay, P, Q followed by P. P also direction, I never change. And then followed by R, R also this direction. So now you can see Q, P, R can be joined up to form a triangle in one direction, which is anti-clockwise. So when the 3 forces, you can join them up to form a triangle in one direction. It shows that the 3 forces are in equilibrium. The 3 forces are in equilibrium. You can join them up to form a triangle in one direction. Okay, another way to join, you see now, I use another way. P, I put here. P, then Q, I put here. P followed by Q, then R is here. No, I never change direction, still the same. P, Q, R also can join up to form a triangle in one direction. Now it's clockwise direction. Understand? So when you can do like this, you join up the forces to form a triangle in one direction. It shows that the 3 forces are in equilibrium. So you say, when three forces in equilibrium, the triangle of forces is in one direction. One direction either clockwise or anti-clockwise. Okay? Yeah. I'm sure some of you will ask, why this one like this? Why not here? Why go opposite direction? Okay, don't be confused. What I just taught you just now was checking whether the forces are equilibrium or not. How to check? To check means you join them up, see whether can form a triangle in one direction or not. Very obvious. This got two examples already. You can join up the forces to form a triangle in one direction, anti-clockwise or clockwise. When you can do like this, it's proven the three forces are in equilibrium. I know some of you asked one. Okay, another one the one what you learned last week was like this, this one is fighting the resultant force. Okay, hold on like this. This one is 12, 20. This arrow is from here to here. This is not checking the forces equilibrium or not. No, this is fighting resultant force. To fight resultant force means you join the starting point, ending point, arrow like that. This is not checking forces in equilibrium. This is calculating resultant force. When calculating resultant force, to join up starting point, ending point. Okay, find the value. Don't confuse. This one is when you are asked to calculate the resultant force like that. Okay, so what you learned just now was you check whether the forces are in equilibrium or not. You are checking. You check the forces are in equilibrium or not. When you want to check, so you join the three forces, see whether it can form a triangle in one direction or not. Now you can form like this, or you can form like that, right? So you show that three forces are in equilibrium. Okay, understand? Understand? Okay, come let me ask some question because just talking like this are hard to know whether you understand one or not. Okay, when I call your name, so you please come out. Okay, Nicole Tan, can you come out? Nicole? Nicole. Okay, I want to ask you one question, Nicole. What is the meaning of forces in equilibrium? What is the meaning? When we say forces are in equilibrium, it means what?
The object is in a state of equilibrium when the force acting on the object is zero.
When the net resultant force is zero, resultant force is zero. Or we say when the net force is zero. Okay. Yes, correct. Nicole, thank you. The next one I want to call this Cecily. Cecily, can you come out?
Yes.
Cecily, how to determine whether the forces are in equilibrium or not? How to determine that? How to determine whether the forces are in equilibrium or not? How we determine?
Check the state of the object, whether it is in stationary or constant velocity.
Okay, correct. Can also. Thank you. What Cecily Chin say is correct now. You want to know whether the forces in equilibrium, you just check the condition of the object now, whether the object stays stationary or the object is moving at constant velocity. Then forces in equilibrium. Okay. Yeah. We have another way to check the forces in equilibrium or not. No. Another way, how to check it. Can you come out?
Yes, sir.
Okay. Another way to check the forces whether in equilibrium or not is how to check. Can you?
When the forces join together to become a triangle, it will be in one direction.
Yes, very smart answer. Correct. what Ken Leong says is correct, you can join up the forces, see whether it can form a triangle in one direction or not. When it can do like that, mean proven the three forces are in equilibrium. Understand? Yeah. So I hope you understand all these things, you take some time to digest, okay. All right, come, let's move on. Okay, this one done already. Now is example, okay. Example, this one more difficult already, because it involve resolution of forces, involve forces in equilibrium. Okay, come look at this question. The following figure show a steel spear. This is a steel spear. 12 kilogram means 120 Newton. Okay. Suspended from the length of rope, which is pulled to the side by horizontal force M. The tensions of another rope is N. Okay, you see now, you are pulling the thing, pull it here. Okay. Pull it here, then to make this thing hanging there stationary. So now there are three forces, One is weight, one is a tension. Tension is here, tension. Because you are pulling like that, I show here got tension 1. Inside the string here got tension N. This is pulling force. So now there are three forces here. This one is pulling force, this is a weight, and this is a tension. If you don't know, you jot down. M is pulling force. This one, W, is the weight. And this N is the tension of the string. Tension. Okay, now the three forces must be in equilibrium, or else this object will not hang stationary. When this object hanging here stationary, show that 1, 2, 3. The three forces must be equilibrium. Understand? The concept is like that one, Since the ball is hanging there stationary, means the three forces acting on it must be equilibrium. So M, pulling force, this one W, the weight, and the tension N, all must be equilibrium. Okay, now the question, draw triangle forces. I draw like this, Okay, so W I put here, 1, 2, 0, W. Then followed by M, that direction, so like that. M, tension. Now you see, I never change the direction. I just join up 1, 2, 3. So Memang is correct. The three forces can be joined up to form a triangle in one direction. Okay. W, the weight, go down. Then M I put here. And the tension is go up. Okay. Correct. Memang is correct. Okay. Join up to form a triangle. So it shows that the three forces are in equilibrium. Okay. Next one, calculate the M and also the N. M is here, N is here. How to calculate? How to calculate the force M and the N? Okay, it's like this, class. This 120 is in the vertical direction. Once it's already follow X or Y, vertical is Y direction. So you don't need to open up, don't need to break, don't need to resolve, leave it. And this M is horizontal, same direction with the X-axis. So it's already okay. Don't need to resolve. So what you need to resolve is only the tension N. I say it again. When the force is already follow Y direction, follow X direction, right? Don't need resolution. Don't need split it out. No need. Only this force N you need to break out because this is not vertical Y direction, not horizontal X direction. So what you need to do is, as normal, I told you, you break the force up to X and Y. X direction is here, Y is here because it's going here, so the X might go to the left, Y go up. Okay, since the angle here 30, Z like that, so here also 30, right? Same, this angle, same. When the angle 30 is here, so this one become cos. N cos 30, so it's here. This component is N cos 30, okay? Understand now? No, since we know this angle 30, so you make this one cos N times cos 30, you get this one. When this is cos, definitely the other one, no angle one, becomes sine, and sine 30, okay? Understand? You must know all cos when the angle is here, so it's cos. This one no angle one, so and sine theta. Okay, now you take the opposite pair to find M and N. So what we do is like this, the opposite one, I think I take this one easier. Going up, same as the one going down. This one going up and cos 30. Going down, 120. So these two must be the same. So N cos 30 equal to 120. So you can calculate lah. So what is the value? So you get this answer. Now you see. Now it's here. The one going up and cos 30, going up and going down must be balanced. So same lah, and cos 30 same as 120. Cos 30 bring here, so you calculate. So N you get 138.56. So you got the tension already. So tension force here is 138.56. Okay, another one to find is M log. When going up, same as going down. So the other one, sure, you take one is going to the right and going to the left, same lah. So it's like that law. Going to the right is M. M must equal this one going to the left and sine theta. Correct not? Just how we say up and down same. Now right and left must be the same. So M equal to N sine 30. And you got the answer, substitute, press calculator, you get this answer. So solve already lah. You see, using equilibrium concept, okay, and also using the resolution forces concept, so we can manage to solve the question. Understand? Yeah, take your time, go and understand it now all. Okay, finish. All right. Now finish already. I want you all to answer the objective question. Okay, start answer the objective question now. Okay, answer all the objective question. Okay, start from question 1, 2, 3, 4. Okay, answer the objective question. Okay, I give you some time to understand, to answer it first. Okay, do now. Yeah, answer now. Answer the question. Okay, how? Okay, come, let's check the answer. Number one, how? What is the answer? Carline, question one. How do you think? Which of the
D.
following object acted by a pair of forces will accelerate? How do you think?
D.
Yes?
D.
Yes, correct, donkey. Why you choose donkey, Carline? Why?
Not the same
Not the
force.
same. Not the same. Or we say not zero. Okay, you see, yes, your answer is correct. The rest are all zero, see, 10 to the left, 10 to the right, you will cancel, 0. This one 5 to the right, 5 to the left, opposite direction, also cancel, 0. This one to the left, to the right, opposite, when you combine, also 0, except this one. This one, when you combine, is not 0. 3 to the left, 2 to the right. When you combine, you will get -1, something like that. It wouldn't become 0, right? When you don't get 0 means there's net force. When there's net force, there is movement. Okay, that's why the answer is D. Okay, thank you, Kalai. Okay, now question number 2. So how? Question is like that. So the friction between the block and the paper, when we move it, there's a friction of 2 lah. Okay. So now the question is, which pair of forces F1, F2 causes the wooden block to move with acceleration? Move with acceleration means you must have extra force, you must have net force. So which pair of force when you combine, you will get extra force one. That one will make the object to accelerate. Okay, now let's hear from, I want to hear from who already? Law, where is Law? This Law very quiet. Never see her. I saw her name just now. Law Yong-si. Law Yong-si? Law Yong-si, can you come out? Law Yong-si. Shannon, can you come out, please? Shannon? All disappeared already. Yong Jia-wei? Yong Jia-wei, are you around?
Yes, sir.
Jia-wei, for this question number 2, how do you think which one is the answer?
E.
Yes. Why you choose E and your answer correct? Why?
I minus the 2 force and minus the frictional force.
Yes, correct. Then you still have extra force, correct not?
Yeah.
Correct. Thank you. You see, A, 7 minus 5, you get 2. 2 is same as a friction now, mean not bigger than the friction. That means you the extra 2 cancel by the 2 Newton of friction. So no extra force also. Only this one, 4 minus 1, you get 3. 3 is bigger than the 2. That means you got extra 1 Newton of extra force. So it will accelerate. Now I say it again. The difference between the two, 4 minus 3, 4 minus 1, you get 3. 3 Newton force is larger than the friction. So 3 minus 2, you still got extra 1. When you have extra 1, means you got excess force, you had net force. So object will accelerate. Okay, I hope you understand. Okay, number 3, the answer is already here. Now you can see. Apply F equal MA. F is 8, M is 0.2. So calculate, you get 40 lah. Very simple, straightforward. Okay, straightforward. Okay, number 4. Number 4, anyone want to give answer? Figure show object 2 kg pull on floor by force 15 Newton, friction 3. friction is 3. And now what the question asks about? Someone give the answer already. C. Ji Hao says C. Let's see. Yes, correct. Ji Hao, you are correct. Answer C. No, you see the solution here? Net force is 15 minus 3. 15, friction 3, so you minus lah. And A 6 lah, so you get 6. Okay. So this formula is very useful, you know. There's a lot of questions can be solved using this formula one, okay? Okay, number 5. The answer B. And now, see the solution now. A box makes 3 kg push along a rough surface with a force 10 Newton. Acceleration 3. What is the frictional force? Now you see, net force F equal to ma. Net force always take 10. The pulling force minus the friction. Small m is a friction. Because the question say got friction they ask you to find the friction. So the pulling force is 10. Pulling force minus the friction equal to ma. M is 3. Acceleration is 3. So you solve the equation, so you get friction 1 Newton. Okay, so far can understand? Hashini can understand?
Can, sir.
Can, okay. The next one, number 6. Number 6, how? I give you a little bit tips. Use this formula. I use this formula to find. A car mass 1,200 traveling at 20 meters per second is brought to rest over distance 40. Find the average braking force. How to solve it? Anyone can get the answer for this one? Okay, work it out first. Okay, try. Yeah. Anyone got the answer? You don't want to say now, you type it out. Anyone got the answer or not? But I think someone typed it. Okay. This one come from Hashini. Hashini say answer D. Yes, Hashini, you are right. Correct. Very good. Well done, Hashini. 6,000, sorry. First, use this formula. Find the A, acceleration. Final velocity V 0 because he say brought to rest. Rest means the final velocity 0 lah. Initial velocity 20. Displacement, the distance 40. Okay, find A. Solve equation here, A -5. Once you know the acceleration already, to find the braking force, find the force, you F equal to ma lah. M times A. Don't need take negative, just put 5. So 6,000. Okay. So the force applied by the brake to stop the car is 6,000 Newton. Okay. All right, number 7. A little bit tips. Okay, now you see. I'll let you see a little bit formula for the okay. Can anyone got the answer? Don't worry your answer right or wrong. Just type your answers. Another one. Justin. This time it's Justin. If Justin say answer B. Yeah, B. I'm not sure it's correct or not. Let's check. Yes, correct. Justin, you are right. Thank you, Justin. 0.02. So it's B. Okay. First, use F equal to MA, find the A. Okay. 250. And now use this formula to find the time. How long will the force act on the particle? Okay, use this to find the time, use this formula lah. Acceleration is V minus U over T ma, A250. Final velocity 15, initial 6, 10. All this given in the question already. Then you find the time, solve the equation lah, 0.02. Okay. Yeah. Okay, number 8. When the equilibrium is reached, this question very simple. Then I want to hear from Lim Jia Xuan. Lim Jia Xuan? Lim Jia Xuan, are you there? Lim Jia Xuan, are you there? No? No sound already. Lao Yixin, sure around one. Lao Yixin, are you there? Lao Yixin? Lao Yixin say yes. Lao, can you give the answer for number 8? What answer, Lao? When equilibrium is reached an object, she say answer C. Lao Yixin says C. Okay. Yes, correct. The answer C. Is either remain stationary or move at constant velocity. Just some I mentioned many times already now. C. Okay, number 9. This one. Which of the following show the 3 forces 5, 12, 13 in equilibrium? How to check? Just now I say, you must join the 3 forces. You see which one can form a triangle in one direction. I repeat again. Without changing the direction of the force, you join the 3 forces to form a triangle in one direction. Only one answer, A, B, C, D can, only one only. So, which is the one? Which is the one can join up to form a triangle in one direction? Okay, I check the answer here. Someone saying this is Law Yong-si. Law Yong-si say answer is C. Okay, let's see. Law. Yes, correct. Law, you are correct. Law Yong-si, well done. C, the answer C. Because only C you can draw like that. The rest are all cannot. This one, 12, 5, 13. You never change the direction, 12, 5, 13. In one direction, what? Inside the answer is C. The rest you try to draw, cannot one, You cannot join up to form a triangle in one direction. Only C. So the answer is C. This one is in one direction, all same is in one circle. One direction. So C. Okay, hey, this question sure come out one, you better know how to check the forces whether in equilibrium or not. Join up, see whether in one direction or not. Very common come out in the SPM one, okay? In the school exam also very common one. Okay, next. Again, number 10. Asking the same thing. When you join F1, F2, F3, so which diagram is correct? Okay, someone give the answer already. Chloe, I need to go now. Okay, Chloe, you can leave now. Chloe, make sure you follow the remaining of the lesson watching the video lah, huh, Chloe? Okay. Okay, you can go now, Chloe. Okay, bye-bye, Chloe. So number 10, which one is the answer? Now I want to ask this Menti Tay. Menti, number 10, what answer, Menti? Menti? Okay, Menti give answer, boy, she said B. Okay, let's see. Yes, correct. You are right, Menti. Thank you. B. This one join up in one direction. Okay, you see, F3 is here. F1 put it here, no? Direction same. Then F2. So this one join up in one direction. So the answer is B. 3 forces join up in one direction now. Okay, all right, number 11. This one a bit difficult. Now I got a little bit tips here. The answer also came out already. What is the magnitude of force P? Okay, and now you see how to see. You check yourself how to solve the equation. Okay, P is follow y-axis. Don't need resolve. Q follow x-axis, so no need change. Leave it. Only this one need to break out. 10 Newton, you break to x-axis, y-axis, but it's going to the left, going down. Understand? Because it's going this direction, so the x component must be to the left. The y component must go down. Okay. Since given here 120, so this angle 60. So we use this angle 60, so this one become cos. 10 cos 60. The one near the angle, so it's cos, 10 cos 60. When this is cos, this one is sine. Got it or not? This is cos, this is sine. But the question asks, what is the magnitude of force P? P go up, same as one go down, correct not? So to find P mean P equal to 10 cos 60 lor. Going up, going down must be the same. So P go up equal to 1 go down, 10 cos 60. You calculate, you can find. This is the answer 5. Okay, this kind of question you must know, have to learn, no choice. So it's like that, from 5 already, okay? Especially you must know how to pick up, which one is cos, which one is sine. You have to be very, very, very sure. It's really very simple. You just see where is the angle. The one near angle is cos. The one no angle given one, sine. Okay, that's it. Okay, okay, number 12. This one even more difficult. Okay, come. I want you to work. Try work out first. Try now, okay? Try to figure out what I wrote there now, okay? Try, okay? Okay, come. Anyone, any suggestion? Anyone want to give answer? Anyone got the answer for question number 12? Got or not? Okay, someone got, I see, Justin. Justin said the answer A. Yes, Justin, you are right. Okay, thank you. Justin, very good. Yes, the answer is A. Okay, come. Why is A, you see, Okay, there are three, this one going down 20. This one pulling force, this one tension. Now the question asks to find the tension L, isn't it? Okay, this one follow Y direction. No need to resolve. This one follow X direction. No need resolve. You only need to resolve this one, open up this one. So you break it up to, because the angle here 60, I use this angle 60 lah, here 30, 60, right? So when I refer to angle 60, this one become cos log. I don't take angle 30, I take 60. When I take 60, so this is cos. So the tension L times cos 60, I got this. Why I take this one? Because I want to write this one going up, same as the one going down to find the L. Going up, same as going down. So L cos 60 equal to 20. Okay, so you get 40. That's the way. Okay. So we have to be a little bit smart now how to choose to solve the problem. Okay, by taking this one, go up, same as one go down. Okay. Yeah. The rest okay, have to work harder to understand it now. Okay. Okay, now we look at next question. This one also a difficult question. Okay, I show you the diagram first. But I don't give you the answer. The diagram is roughly like that lah. So how to solve it? Same thing, I think find the tension also. You are asked to find the tension. Okay, a little bit more lah. Find the tension. Any idea? Anyone got the answer? Ask so many smart people here. Anyone got the answer? Anyone managed to get answer? Ken Leong, Kelvin, or this Zhao Xian. Anyone got the answer or not? Yes?
Elephant.
May I know who is answer? Who is answering? Ken Leong
Ken Leong.
Elephant Okay. Let's see. No, not elephant. So the answer C. Okay, someone give the answer here. Let's see. Justin correct. Justin say answer C. Justin correct. Okay, now see lah how to get answer C. Right. I draw the diagram here lah. So the length is 2 Newton. 0.2 times 10 0.2 kilo is 2 Newton lah. And then this one tension, right? Okay, now when this is 35 here, this one 90, here is 65, 55, sorry. This angle 55, so I think this angle 55 is here. 90, 35, so here is 55, let's put it here now. Okay, now to find tension, this force has to be resolved and open up. So this one open up to Y and also to X. When you open up Y, when you take angle 55, so it's cos. So T cos 55 got 2. Y got 2, one on the left, one on the right. So that's straight away times 2. You got 2, This one you bring here is also T cos 55. This one you bring here is also T cos 55, so got 2. So 2T cos 55, they want go up, got two, one here, left, right got two go up. Balanced by the 2 Newton. That's why here. 2t cos 55 equal to 2. 2 cancel. So bring this one over, divide. So you get this answer 1.743. Okay. So you all must be very smart to resolve, to open up the force, to open up the force and then use the component to solve the problem. Okay. Study again the question 13, go and understand it. Okay. Yeah. Okay, come next question. Okay, this question let me explain. I think I need to explain this one to you. Okay, come. Can everyone listen? Listen, this question. Actually, this question came out in the SPM, quite tricky one. No? Okay, come. Figure show 3 identical pictures hung differently on the wall. There are 3 different ways to hang the drawing on the wall, They are asking you, which comparison is true about the tensions of each string? Okay. Tension of the string, they want you to say which one tension is the highest, which one tension is the medium, which one tension is the lowest. The lowest tension means is the best way to hang pictures. So the best way to hang pictures, don't be surprised, actually is R. You hang the picture this way now, so the string will last long time. It won't break. The best way actually is R, because the tension here is very little, very small tension. Okay. Whereas the first method not good. First method, okay, not good. You know why? When this angle is small, when the angle is small, the tension become very high. When the tension become high, the string very easy to snap, so it won't last long. So according to the tension, right? So the highest is here, followed by here, and last one, the lowest tension is here. Okay, now let me explain why. I take this diagram to explain to you. Let's say this angle theta, this is also theta. Tension is here. So this is T sine theta, correct not? Angle is here, so here no angle, so T cos theta is here. This is cos, so here this is sine. T sine theta, isn't it? So the one go opposite to the weight of the drawing is T sine theta. One here, over here got another one T sine theta, right? So 2T sine theta. These two are the one who supporting the W. Okay, I explain one more time why T sine, because I will take this tension T, angle theta. So near the angle, so this is cos, T cos theta. So this is T sine theta, one here on the left. On the right here also got one. So 2T sine theta supporting the weight W for all the pictures same. 2 d sine theta equal to the weight of the drawing. Okay, now you see T equal to W divided 2 sine theta. Okay, what you can see from this equation is when the angle theta big, this one very small, theta bigger, and then this 90 degrees is the biggest. When the angle theta is big, this number here become bigger. So you divide by a bigger number, your answer becomes smaller. Say it again. When the angle theta is big, so W divided by a bigger number, so your answer tension becomes smaller. So among the 3 diagrams, this theta is the smallest. This theta is a medium. This theta 90 is the biggest slope. So when a theta the biggest, so the tension becomes the smallest. Understand? So when you compare the tension, the highest tension is here. So next time, don't hang the pictures like this. When you make this angle very small, actually not good one. The string very easy to snap. Okay. Normally we put like this lah. This angle is big as possible. Also the best is 90 degree lah. You hang like this, 90 degree, it will last long time, but very ugly, right? Normally we hang like this lah. As long as this angle is big, then the tension will become small enough lah. Okay, so the answer is the highest tension is here, followed by here. Then this is the smallest tension. So answer A. Yeah. So next time you remember, hanging, you see, this angle small means the tension become very high. When the angle big as 90 degree, the tension very small. Okay, Okay, now, so this question, the answer is A. The next one, number 15, what answer? Someone please give the answer. Which of the following produces a largest resultant force? Very simple. Which one give the largest answer? Largest resultant force. Sherry's Lim. Okay, Sherry's Lim, very quiet. Hong Zhao Xiang says C. Yes, correct. The answer C. See? This one you get 22. This one same direction, add up 18 only. This one opposite direction minus 16. Same direction you add up but 14 only. So this is the biggest lah. See, Okay, number 16. Okay. Tips, I give you tips there. Okay. Use a diagram given, okay, to find the answer. Someone got the answer already? Nicole, Law, these two good friends, Law Yong-si say answer A. Nicole Tan say answer donkey. I'm not sure which is correct now. Justin say donkey. Yeah, okay, come, let's see the answer. First, this diagram you all must understand, what is the angle between the resultant force? This one is resultant force, not forces in equilibrium, not one direction, no. So 3 followed by 4, So resultant force is from starting point, connect to the ending point. So direction is here. So by Pareklus theorem tell us 3, 4, 5. So it must be 5 now. But the question asks for the angle. Angle between the resultant force to the force of 4 Newton means 5 this angle lah. This is the angle between the resultant force and the 4 Newton. So find this angle. To find this angle, use tangent. Tangent, huh? So tangent is opposite over adjacent. OA. This angle is here, opposite is 3, adjacent is 4. This is hypotenuse, right? 3 over 4 lah. So use a calculator. Shift tangent 3 over 4, you get 36.9. So answer donkey. Yes, Justin correct. Nicole also correct, I think, right? That means there must be people can get the answer one in this group. Every time I ask any question, sure got someone get the answer one. Justin D, Nicole Tan also D. Yes, correct. Both of you correct. Okay. Okay, last question. Figure show 2 forces, 5 Newton, 4 Newton, act at point, make an angle 60. Okay, now like that. 60. Okay, can you find the answer, resultant force? I suggest you draw lah, use triangle method. Okay. Because calculation method not easy one, you know. You need to take X, take Y, then find resultant force. Okay, use a basic method first lah. Because even though in the SPM they ask you to draw. Okay, use triangle method. Okay, use a triangle method to find the answer. See, anyone can get the answer. If you draw properly, draw the triangle properly, you will get the answer very easy. So what is the answer? Anyone got it or not? Use drawing now, triangle method, okay? The diagram is, I don't show you the full diagram first. Now you see roughly it's like this. 4 Newton, you draw 4 cm. 4 cm. 5, this angle 60, so here 60, so here 150 law. 60 is here, So use a protractor to measure 120, then draw 5 cm. Then you get the answer already. 4 cm here, exactly, angle here 120. Because 120, the reason is why that? Because you see here is 60, so when 60 here must be 120. This one I'm moving over here. Draw 5 cm, 4 cm, 5 cm. Then you join up the starting point and ending point. That's it. You get the answer. So what is the answer? Someone got it already, I think. Nicole Tan says C. Yes, correct. Nicole, you are very good. Nicole Tan, yes, correct. Yes, you draw properly, you get 7.8. 7.8. 60 degrees here. So here you measure 120 lah. Then 4 cm, 5 cm. This angle correct. Then you measure here 7.8. You get the answer 7.8. That's it. Triangle method. And last, okay, class, I need to introduce to you one formula lah. This formula lah is just for you to check your answer lah. You will learn this formula in your additional maths. Cosine rule. Solution of triangle, yeah, cosine rule lah. Okay, you learn in Form 4, isn't it? Is it Form 4, Justin?
Yes.
Form 4, yes. Cosine rule lah. But in physics, they don't recognize this, So this one just for you to check answer, for you to find answer for objective question can lah. Okay. Yeah. Okay. Well, the moment you have this diagram already, you don't let's say you don't have a compass protractor to measure, doesn't matter. You just sketch it out like that. 4, 5, angle here 1, 2, 0. You want to find this, right? You cosine rule lah. R, so R square equal to 4 square plus 5 square. The formula, cosine rule, you all learn one, isn't it? R square equal to 4 square plus 5 square plus 2 times 4 times 5, right? Cos 120. You want to find this, so you take the opposite angle 120 lah. This one cosine rule, I think you refer to your MX that you have learned in Form 4, right? Then you calculate, you get 4.8, also the same. This one is for you to get answer faster in the objective question, no? Cosine rule, okay? Yeah. Okay. So I think tonight I stop at question number 17 now. Okay. The rest of the question you all try first lah. Okay. Okay, here. I hope at least you can understand 60-70% at least lah. Of course, some of you, I know you can understand a lot. Okay. Try to work harder, okay? Some difficult one, so get it to understand. Read it again, okay? Okay, anyone want to ask any question here or not? Justin, you got anything to ask, Justin?
No, sir.
No. Cecily, anything to ask or not?
No.
No. Cheris, anything to ask?
No, sir.
Carline, any question?
No, sir.
No, sir. Hashini? Hashini.
No, sir.
Oh, no question, no question. Okay lah. Work hard, you all. Work hard, can read through all the solution. Some calculation part, you need to take time to understand it. Okay. So, take good care. Continue to struggle hard. Okay, for Form 5. So, don't rest too much. You need to study. Okay, I see you again next week. Okay, bye-bye. Okay, bye-bye.
Thank you, teacher.
Bye-bye. Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, bye-bye.
Thank you, sir.
Bye-bye. Yeah, bye-bye. Okay, bye-bye, everyone.